Hi guys. Not many of us did our work last week, so I just want to make sure that everybody's on the same page with how to tell the difference between linear and exponential functions. So the keywords for either of these two, let's start there. The keywords to tell whether something's linear or exponential. The linear words might be things like adds, less than, the word more, per, or each. Those are some keywords that can be used for linear. Exponential functions usually we use words like half, double, triple, or using any kind of percentage. If they have a percentage, that's going to be more exponential. Okay, let's go ahead and take a quick look at linear. We'll zoom in on linear real fast here. So if we're looking at a linear function, we're going to have our graph, which is going to be linear, which means just a straight line graph. So it looks something like that. And it grows, you guys know this, through adding or subtracting. We've known that for a long time here. It grows by adding or subtracting. So if I were to give you an example, we could do something like 3, 5, 7, 9, and it keeps on going. We're adding by 2 each time. So knowing that, my equation, I would have y equals. Normally, linear equations are written in the form y equals mx plus b, with your m being your rate. Remember, your rate is always by your x. That's the thing I wanted you to learn the other week. Your rate is always by the x, and your b is your y-intercept or your starting number. So when we're looking at this one, I have y equals my rate. What is my rate each time? It's going up by 2, and it's going to be adding 2 each time, so it's a positive 2. And a faster way than saying 2 plus 2 plus 2 would be to multiply it, so I have y equals 2 times x. And I started that pattern starting at the number 3. So that would be my equation right there. Okay, let's go ahead and let's see, actually this is exponential or linear growth. We can see this is growth because it's going up. Linear decay, if we wanted to talk about a negative slope, it would be going the other way. It would be going down instead. All right, exponential growth. So let's take a look at this one here. This one here, you guys know it grows by multiplying or by dividing. And an example of that one might be something like 5, 10, 20, 40, and so on. And that one there, we're multiplying each time by 2. So our equation is usually in the form y equals a times b to the x. Remember, your rate is always by your x. So your rate is going to be your b, and your a is going to be your starting or your initial point, also known as your y-intercept. So for this special equation here, I would get y equals my starting number, which is number 5. Number 5 is my starting. I'm going to be multiplying each of these by the rate, which was multiplying by 2 each time. And something faster than multiplying 2 times 2 times 2 is raising it to the x power. Okay, exponential, if we want to look at the function of that one here, the y-intercept was 5 in my example, so I'm going to start at positive 5, and it's going to double each time. And it's going to look something just like that. That's going to be called exponential growth because it's going up. Exponential decay, on the other hand, is going to look something like this, where the graph is going down from left to right. Okie dokie. Oh, this is the part where it's a little bit harder. All right, so with exponentials, I did tell you as part of our keywords that you could use any type of percentage. That was going to be exponential. So if we wanted to look at your percent growth, say, I don't know, you put $200 in the bank. $200 in the bank. It grew at a 5% interest. You got it in a super high yield savings account. Let's figure out how to write that. So if it's percent growth, you're always going to be adding 1 to your rate, and we'll talk about that in just a second. it's going to be 1 plus your rate. For percent decay, it's going to be 1 minus your rate, and we'll talk about that in a second too. All right, so first we got to look at our equation. We're going to start at our starting point, which is 200. Y equals $200. And we have a 5% interest. We can't put percentages into our equations. We have to convert that to a decimal. Okay, so 0.5 into a decimal. Oh, I'm already giving the work. I'm already giving the answers out. 5% as a decimal. You're going to move that decimal 2 spots over, just as you told me in the past. You're going to get 0.05. But know that this is growth, and the rate has to be bigger than 1 in order to be growth. So I'm going to add a 1 to it. So 1 plus 0.05 is my new growth rate. In which case, I can just fit that in here. So I'm going to have y equals 200 times 1.05 to the x power. That becomes my new equation. Okay, and for growth, or for decay, let's say that we started with the same amount, $200, but it was a painting's worth, and the painting depreciated, so the value went down. It depreciated 2%. Okay, let's figure out how to write that one. So we have our $200, which we started out with. We went down 2%. We can't write percentages in our equation, so we're going to make that a decimal by moving the decimal 2 spots over. Right now, I'm asking how much the painting was worth, so I'm going to have to subtract 1 from it. So 1 minus 0.8, it lost 2% of its value, but it still has 98%. So we're going to figure out what that, becomes. So we're going to have y equals 200, that's my starting amount, times, you can put this in your calculator, 0.98 to the x power. That's going to be your new equation there as well. Okay, that was a quick crash course on linear and exponential equations. Let me know if you guys need any help. Hopefully that was everything that you need. Have a great day, guys. Bye.